Okay class, what I want to do today is just go through the practice task real quick to show you how I approach it, and hopefully this will help you with some of your feedback before we do the assessment tomorrow. So I'm in the student zone here, and I'm going to click on Start Assessment, and we're going to work through it. And hopefully it should be similar to your experience. So I'll just skip through the first parts. Next. My name. Today is the 5th. Doesn't matter. Okay. So this is about 3 different taxi companies and trying to figure out which one is the cheapest. So we're using linear equations, and we get 3 things. So we get a table, which we have to derive an equation from. We get a sentence, and we get a graph. So it's pulling those 3 skills together. So the first thing I'm going to look at is blue taxis and look at the table. And what I've got is these distances, and I can plot these points on the graph, and I only need to plot 2 points. So the points I'm going to plot is 0, 3. So if I go down, I go 1, 2, 3. So there's 1 point, and I'm probably pretty gumby with this. And then I can put another point at, where's a nice point? We're going to go up in 1.7s. So maybe I go 5 and 11.5. So I go 5 kilometers here, and I'm going to go to 11.5, which looks about there, right? So halfway to. And then I can just put a straight line through those 2 points. That's really all I have to do. And there's my blue taxi line. If I'm going to write this as an equation, I know my y-intercept is going to be 3. And each time it's going up by 1.7. So I'm going to write my equation in here. Y equals 1.7x plus 3. Okay. The next one is green drivers charge a flat rate of $25. So it's flat up to 20 kilometers, which means up to here. So I'm going to use the green line, and I'm going to go to 25 the whole way up to 20. And then I stop. And that's all done. So that means my green line is going to be y equals 25. And that's it. Now for gold, I'm going to have to look at the chart. And I can look at where does it start, and I can see it starts at 5, 6, 7, 8. So I know my y-intercept is 8. So it's going to be y equals something x plus 8. And now I have to find my gradient. And how I'm going to do that is I'm going to look at the rise and the run. So I'm going to go, how far up does that go? And how far across? Between these 2 points that they've given me. So I've gone across 15. And I've gone up from 8 to 26, and that's up 18. So that's my rise, and that's my run. So my gradient is going to be 18 over 15. And if I use a calculator, or I can simplify that down to 6 over 5, I'm going to see that's 1.2. Oh, it doesn't show there. 1.2. So my gold one is going to be y equals 1.2, or $1.20 per kilometer, plus my starting point, which was 8. So that's what I have to do. Is I've got my equations, and then I plug them in to find all my different distances. This one's nice and easy. It's 25, 25, and this is going to be 50, because it was 25 for the first 20 kilometers, and then I add another 25. And then we just put in the different numbers here. I'm not going to do this right now, but have a quick look. So I'd have to go 1.7 times 5.5, and then add on 3. So this is going to be $12.35. I'm going to complete that table. And then to finish, I have to write 3 sentences, one for each of the 3 trips. So from Roscoe to Avondale going 5.5 kilometers, the cheapest is going to be, let's say, blue taxis, which is the cheapest, costing, you say, $12.35. And all you have to do is write that for each of them. The next one is for Avondale to Milford, use green taxis, which is cheapest, costing $25. And then lastly, for Mission Bay to the airport, use gold taxis, costing, which is cheapest, costing, and then you're going to put the cost in there. And I can have a look. It's going to be 1.2x plus 8. I'm going to put in 22.5. So I can go, that's 1.2 times 22.5. So I'm going to clear that. Start again. 1.2 times 22.5 plus 8 is $35. But I'd have to do all those numbers. So that's the achieve section there. And what I can do is if I flip to Desmos, I can put those onto Desmos and just test it out. 1.2x plus 8. 1.7x plus 3. Another one is y equals 25 for x is less than 20. So I can also put these points on Desmos. And if I play around, I can kind of get the same kind of lines, and I can use that to check my answers here. So my first answer, that's for achieved. The next one wants to know what distance does blue taxis and gold taxis charge the same amount. So we're looking at when they cross each other. Now I've already kind of done that on the previous one, but what I can do is I can have a look in Desmos. So I've got my blue taxi line here, and then I've got gold taxis, and I can change this color. Oh, no, I can't. And I can see, oh, they cross here. And I click on the point, and it shows me it's crossing at, the distance is 10 kilometers, and the cost is 20. So that's going to be my intersection point. So I can say here, it cost the same at 10 kilometers, both cost $20. And to prove it, I want to show that 1.2 times 10 plus 8 equals 20. So that's the gold taxis, 1.2 kilometers, dollars per kilometer times 10 kilometers. The other one was 1.7 times 10 plus 3 also equals 20. So I'm showing that both those equations, so that's gold taxi, this is blue taxi, both cost the same when x is 10. And I can draw it on the graph as well. So that was starting at 3. I had 1 point there. And I know it goes through that line over here. So there's my blue line. And then I can draw the point here. That's where they cost the same. So blue taxis is cheaper up to 10. And after that, gold taxis is going to be cheaper. And that's merit. Lastly, the excellence section. You guys have done this pretty well. What I want to do is I've got to put in my two lines. So I've got gold taxis in there, and then there's green taxis. So my first option is to find something that starts cheaper. So maybe starts $1 cheaper here. And maybe ends $1 cheaper there, right? So here's a line. It starts here at, if that's 8, it's going to start at 7. It's going to go across. It's going to go across 20. And to end $1 cheaper than green taxis, I have to go up from 7 to 24. So I'm going to go up 17. And so that's going to be my gradient. My rise over run will be 17 over 20. So I can say y is equal to 17 over 20x plus 7. Now, 17 over 20 is not a great sort of number. So we can have a look and see, can I put that as a decimal? So it's 17 over 20, 0.85. Oh, that's pretty good. So maybe a nicer way is 0.85x plus 7. And I can say this starts $1 cheaper than gold taxi, and at 20 kilometers is $1 cheaper than green taxis. That's one option. It's a nice straight line. Starts $1 cheaper, ends $1 cheaper. That's the first way. The second way is we're going to look at a two-part line. So I'm going to put green taxis back in here. is I want something that looks a little bit like, maybe I can start $1 cheaper, go all the way up, and then when I hit like $24, I can do a second part. I'm going to make that black. That goes across like this. So it's a two-part line. So for my first part of the line, I'm going to go y is equal to 1.2x. So I want to keep the same gradient as the yellow line. So this one's going up at 1.2. So will this one. Instead of starting at 8, I'm going to start down here at 7. So 1.2x plus 7 up to, and I've got to find out, where do I stop that? So I need to find out, I want to stop it at $24, but maybe I can just stop it here at 14 kilometers. That may be one option. That's a nice easy one, right? So let's stop at 14 kilometers, up to 14 kilometers, where it costs, I need to find out how much will this cost for 14 kilometers. So I need to do 1.2 times 14 plus 7. I can do that here. So 1.2 times 14 plus 7. So that's going to cost you $23.80. $23.80. There's my evidence. Then a flat fee of $23.80 up to 20 kilometers, and that's going to be y equals 23.8. It's kind of one way. It's a bit messy having that 23.8. So maybe another way I could have done it, if I just rub this out, maybe there's a nicer way. Oh, assessment error exit. Oh, I lost it. Well, another way could have been, maybe if I started at 6 kilometers, so if I go back to Desmos, I could say, what if I went y equals 1.2x plus 6? So here's my line here. So just under gold taxi, so start $2 cheaper. And at this point here, it's 15 kilometers and costing $24. I could put another line that goes straight across. That's going to be y equals 24. I'm going to start that from x is bigger than 15. There you go. And up to 20. So here's this line here. So I'm going to go up. So I'm going to have this two-part line. So that's for excellence. Mrs. Wright has probably a better materials for excellence. Please have a look at that. The focus is try to get to that merit point for tomorrow's assessment, and then we can work from there and see if there's any other opportunities. We don't know what's going to happen yet, but please do your best with the resources that you have. Doing the assessment is really important to find out where we are at with this at the moment, okay? So please have a go, do the assessment, do as best you can, and then we're going to use the feedback from that to help us go to the next step when we get back to school. Thanks, guys. Thank you for watching. Do your best.